The Advanced Research Projects Agency Network, ARPANET, was the first wide-area packet switch network with distributed control and one of the first networks to implement the TCP/IP protocol suite. Both technologies became the technical foundation of the Internet. The ARPANET was established by the Advanced Research Projects Agency, ARPA, of the United States Department of Defense. The first computers were connected in the year 1969, and the Network Control Protocol was established in 1970. The network was declared operational in 1971. Further software development, it enabled remote login, file transfer, and email. And the network expanded rapidly, and operational control passed to the Defense Communications Agency in the year 1975. Internet working research in the early 1970s, led by Bob Kahn at the DARPA and Vince Cerf at Stanford University and later DARPA, they formulated the Transmission Control Program, which incorporated concepts from the French Cyclades project. As this work progressed, a protocol was developed by which multiple separate networks could be joined into a network of networks. Version 4 of the TCP/IP was installed in the ARPANET for production use in January 1983 after the Department of Defense made it standard for all military computer networking. The access to the ARPANET was expanded in 1981 when the National Science Foundation funded the Computer Science Network, the CSNet. In the early 1980s, the NSF funded the establishment of national supercomputing centers at several universities and provided network access and network interconnectivity with the NSF-NET project in the year 1986. The ARPANET was formally decommissioned in 1990 after partnerships with the telecommunication and computer industry had assured private sector expansion and future commercialization of an expanded worldwide network, popularly known as the Internet. Now, because it was never a goal for the ARPANET to support IMPs from vendors other than the BBN, the IMP to IMP protocol and message format were not standardized. However, the IMPs did nonetheless communicate amongst themselves to perform link state routing, to do reliable forwarding of messages, and to provide remote monitoring management functions to ARPANET's Network Control Center. Initially, each IMP had a 6-bit identifier and supported up to 4 hosts, which were identified with a 2-bit index. An ARPANET host address therefore consisted of both the port index on its IMP and the identifier of the IMP, which was written in a different notation as a single byte. For example, the address of MIT DMG, it was notable for hosting development of Zork, could be written as either 1/6 or 70. An upgrade in the early 1976 extended and the host and IMP numbering to 8-bit and 16-bit were developed respectively. Now, in addition to primary routing and forwarding responsibilities, the IMP ran several background programs, tilted TTY, debug, parameter chain, discard trace, statistics. These were given host numbers in order to be addressed directly and provide functions independently of any connected host. And the TTY allowed on-site operator to send ARPANET packets manually via teletype connected directly to the IMP. Now, in the year 1822, the starting point for the host-to-host communication on ARPANET in 1969 was developed. So, the 1822 protocol, which defined the transmission of messages to the IMP, was founded. The message format was designed to work unambiguously with a broad range of computer architecture. An 1822 message essentially consisted of a message type, a numeric host address, and a data field. To send a data message to another host, the transmitting host formatted the data message containing the destination host's address and the data message being sent, and then transmitted the message through the 1822 hardware interface. The IMP then delivered the message to its destination address either by delivering it to a locally connected host or by delivering it to another IMP. When the message was ultimately delivered to the destination host, the receiving IMP would transmit a ready for next message RFNM acknowledgement to the sending host IMP. Now, the network control protocol was unlike other internet datagrams. It was not like the modern day datagrams, it was different. So the ARPANET was designed to reliably transmit 1822 messages and to inform the host computer when it loses a message. The contemporary IP is unreliable, whereas the TCP is reliable. Nonetheless, the 1822 protocol proved inadequate for handling multiple connections among different applications residing in a host computer. This problem was addressed with the network control protocol, which provided a standard method to establish reliable flow-controlled bidirectional communication links among different processes in different host computers. The NCP later interface allowed application software to connect across the ARPANET by implementing higher-level communication protocols, an early example of protocol layering concept later incorporated in the OSI model. Now, the NCP was developed under the leadership of Stephen D. Crocker, then a graduate student at UCLA. Crocker created and led a network working group, NWG, which was made up of a collection of graduate students at universities and research laboratories, sponsored by ARPA to carry out the development of the ARPANET and the software for the host computers that supported the applications was in process. So the various application protocols such as Telnet for remote time sharing access, file transfer protocol, FTP, and rudimentary electronic mail protocols were developed and eventually ported to run over the TCP/IP protocol suite, or replaced in case of email by the simple mail transfer protocol. Now, Steve Crocker formed a networking working group in 1969 with Vint Cerf, which was also joined by an international networking group in the year 1972. These groups considered how to interconnect packet switching networks with different specifications. That is known as inter-networking. This led to the formulation of the Transmission Control Program, which incorporated concepts from the French Cyclades project directed by Louis Pouzin. Its specification was written by Cerf with Mr. Yogan Dalal and called Sunshine in December 1974. RFC 675 was formulated. The following year, testing began through concurrent implementations at Stanford BBN and University College London. At first, a monolithic design, the software was redesigned as a modular protocol stack in version 3 in the year 1978. Version 4 was installed in ARPANET for production use in January 1983, replacing NCP. The development of the complete Internet Protocol suite by 1989 and outlined RFC 1122 and RFC 1123 was formulated, and partnerships with telecommunications and computer industry laid the foundation of the adoption of TCP/IP as a comprehensive protocol suite as a core component of the emerging Internet. Now, the NCP provided a standard set of network services that could be shared by several applications running on a single host computer. This led to the evolution of application protocols that operated more or less independently of the underlying network service and permitted independent advances in the underlying protocols. Telnet was developed in the year 1969, beginning with RFC 15, and it extended to RFC 855. The original specification for the file transfer protocol was written by Mr. Abhay Bhushan and published as RFC 114 on April 16, 1971. By 1973, the file transfer protocol specifications had been defined and was known as RFC 354 and implemented, enabling file transfers over the ARPANET. In 1971, Ray Tomlinson of the BBN sent the first network email, RFC 524, RFC 561, within a few years, and the email came to represent a very large part of the overall ARPANET traffic. The Network Voice Protocol NVP specifications were defined in the year 1977, RFC 741, and implemented, but because of technical shortcomings, conference calls over the ARPANET never worked well. The contemporary Voice over Internet Protocol, Packet Voice, was decades away. Now, the Packet Protection Protocol, the Purdy polynomial hash algorithm was developed for the ARPANET to protect passwords in the year 1971 at the request of Mr. Larry Roberts, because he headed the ARPA at that time, and the computed polynomial of degree 2 to the power 24 plus 17 modulo 64-bit prime p is equal to 2 to the power 64 dash 59. So this was the password protection Purdy polynomial hash algorithm. The algorithm was later used by Digital Equipment Corporation, DEC, to hash passwords in the VMS operating system and is still being used for this purpose. The French Cyclades computer network, pronounced CICLAD, was a French research network created in the early 1970s. It was one of the pioneering networks experimentation with the concept of packet switching, and unlike the ARPANET, was explicitly designed to facilitate internet working. The Cyclades network was the first to make the hosts responsible for the reliable delivery of data, rather than this being a centralized service of the network itself. Datagrams were exchanged on the network using transfer protocols that do not guarantee reliable delivery, but only attempt the best effort. To empower the network leaves the host to perform error correction, the network ensured end-to-end protocol transparency, a concept later to be known as end-to-end principle. The simplified network design reduced network latency and reduce the opportunities for single-point failures. The experience with these concepts led to the design of the key features of Internet Protocol in the ARPANET project. Instead of having a single inventor, the Internet was developed by many people over many years. The following are some Internet pioneers who contributed to its early and ongoing development. These include early theoretical foundations, specifying original protocols, and expansion beyond a research tool to wide deployment. We must also know about the OPTE project, because the OPTE project visualizes the routing paths through a portion of the Internet. Now, before we dive deeper into the famous Internet pioneers, let's see what the OPTE project is. The OPTE project was created in 2003 by Leonard. It seeks to generate an accurate representation of the breadth of the Internet using visual graphics. Leon believes that his network mapping can help teach students more about the Internet, while also acting as a gauge illustrating both overall Internet growth and the specific areas where the growth occurs. It is not the first of such project. There are others that predated it, such as the Bell Labs Internet Mapping Project. Now, what is the Internet Mapping Project? It was started by William Cheswick and Hal Birch at the Bell Labs in the year 1997. It has collected and preserved trace route style paths to some hundreds of thousands of networks almost daily since the year 1998. Isn't that wonderful? So the project included visualization of Internet data, and the Internet maps were widely disseminated. The technology now is used by Lumeta, a spin-off of Bell Labs, to map corporate and government networks, although Cheswick left Lumeta in the year 2006, September. Lumeta continues to map both IPv4 and IPv6 Internet. The data allows for both a snapshot and view over the time of the role infrastructure of a particular geographical area, company, organization, etc. Cheswick continues to collect and preserve the data, and it is available for research purposes. According to Cheswick, the main goal of the project was to collect the data over time and make a time-lapse movie of the growth of the Internet. Now, some of the other mapping projects are the hand-drawn maps of the Internet from 1973, hand-drawn. And then the Center for Applied Data Analysis collects, monitors, analyzes, and maps several forms of internet traffic data. Concerning network topology, the internet topology maps, also referred to as AS-level internet graphs, they are being generated daily in order to visualize the shifting topology of the internet over time. And as we mentioned previously, the OPTIP project started in 2003 by engineer Barrett-Leon, which is still using traceroute and BGP routes for mapping. Then there's New Hampshire project in 2010, the US Department of Commerce awarded the University of New Hampshire's Geographically Referenced Analysis and Information Transfer NH Granite project approximately $1.7 million to manage a program that will inventory and map current and planned broadband coverage available at the state's businesses, educators, and citizens. As a part of the project, the New Hampshire Broadband Mapping Program, NHPMP, was created as a coordinated multi-agency initiative funded by the American Recovery and Reinvestment Act through the National Telecommunications and Information Administration, NTIA, and is a part of national effort to expand high-speed internet access and adoption through improved data collection and broadband planning. In 2015, Kevin Kelly, editor and co-founder of Wired magazine, he started his own internet mapping project to understand how people conceive the internet. He wanted to discover the maps that people have in their mind as they navigate the vast internet by having them submit hand-drawn pictures. Hand-drawn pictures. Mind mapping the internet by your hand. So far, he has collected close to about 80 submissions by people of all ages. 80 is still way too low. More people need to be submitting hand-drawn maps about the internet. So, these 80 people are from all nationalities and have expertise, all levels of expertise, ranging from concrete to conceptual to the comic. Let's go back to the OPTIP project. Now, the images that were generated by the OPTIP project using the traceroute method, which later switched to mapping using BGP routes. What is BGP? BGP is a border gateway protocol. It is a standardized exterior gateway protocol which is designed to exchange routing and reachability information among autonomous systems on the internet. BGP is classified as path vector routing protocol, and it makes routing decisions based on paths, network policies, rule sets configured by a network administrator. So the project has gathered notice worldwide, having been featured by The Time, Cornell University, New Scientist. And in addition to the OPTIP project maps, they found homes in at least 2 art galleries and exhibits, such as the Museum of Modern Art. You can Google extensive mind map images of the internet to see what Google fetches you. So in at least the 2 art galleries and exhibits, such as the Museum of Modern Art and the Museum of Science, mapping the world around us as a permanent exhibit. OPTA images are licensed under a Creative Commons license, and while the use of OPTA image is free for all non-commercial applications, a license fee is required for all others.